Hello, this is Anantha Gottimukkala, Assistant Professor, KL University. Today my topic is design minimum cost spanning tree. The subject is a design and analysis of an algorithm. The concept is discussed today, minimum cost spanning tree. So before going to minimum cost spanning tree, we will discuss what is a spanning tree. On that spanning tree, so what is the minimum cost spanning tree? To identify the graph, what is the cost of spanning trees? So in this cost of spanning trees, to find out the, so first we will learn as an what is a spanning tree. So here the spanning tree is a graph. The graph is subgraph of G, that is tree, and contains all the vertices of G. For example, that we will discuss, and the graph is having a sum of vertices and sum of edges. So the graph is an allocated sum of vertices and sum of edges. In this sum of vertices and edges is an undirected connected graph. These are the undirected connected graph. In this undirected connected graph, to find out the tree is having a sum of the vertices and edges. The tree is having a sum of the vertices and edges. In these edges, so to find out, so here the tree is contains that to find out the tree is contains the undirected graph, it contains a no cycle, it contains a no cycle. So to find out here, what are the properties of spanning tree? Though here we are finding some of the properties. What are those properties? A connected graph G can have more than one spanning tree. And second one, all possible spanning trees of a graph G have the some number of edges and vertices. The some number of vertices and edges. The spanning tree does not have any cycle. It contains the loop. It cannot be loop in a tree. So fourth point, it removing one edge from the spanning tree will make the graph disconnected. The spanning tree is minimally connected. So and finally, so adding one edge to the spanning tree will create a circuit or loop. That is, the spanning tree is maximally acyclic. So when we have the using of the here, so what are those these properties? We find out the cannot be a cycle. So here we are, these are the some examples of the trees. Here the trees. So first one, the tree. This is the first graph. In this graph is having a undirected graph. In this undirected graph, what are the possibility trees we will connected? So what are the possibility trees we will connected? So by using one of the property, that property is it cannot be allocated in a loop. It cannot be allocated in a cycle. So here, based upon the tree, so we find out into the one of the another subtree. So here the possibility, when we are connected this one, it collected into a cycle. So that's why we are removed the edges into the B to C. We removed the edges into the B to C. So based upon the another tree, so based upon that another tree, so based upon that another tree, we removed the A to D edges. A to D edges. So this is the second tree. So again we will find out into the D. So here the A to B, when we are allocated to the A to B, it is an allocated into the loop. So cycle. Then we are removed into the A to B connection. A to B connection. That means the A to B edges. So what we are having the A to B, one A vertex to B vertex, here we are not connected, because of when we are connected the to A to B, it will be allocated is an loop. So another possibility, A D to C or C to D. When we are allocation of this one, so again we are identified the loop. This is the one of the graph here the graph is an having a trees, so many trees is an possibilities, so many trees is an possibilities. These are the possibility trees to find out into a tree, so without loop, without loop. Okay, so the same one, another example, some of the another example. In this example, same example, the tree. So this is the tree. In this tree is having a some of the weights. Okay, each one, A to B is an a 4, B to C is an a 1, C to D is an a 2, D to A is an a weight 5. These are the weights. Okay, so these are the weights. So A to B is having a weight is a 4. Before check we have, this is a graph. In this graph, so there is no weights. Here second point we will discuss it into the next graph. So here we are using a graph. On that graph is some of the weights. Here what are the weights is having? So each vertex is having a some weights. Okay, same. So spanning tree, one of the property, that property is having a, so the spanning tree does not have any cycle. So does not have any cycle. Okay, so based upon this property, so based upon this property, we are going to the connected to the one vertex to another vertex. When we have any cycle, we are removing that one to one edge, one to one edge. So based upon that situation, so we are having one tree. So in this tree is possible using of the weights. In this weights we are applying for the weights on the vertices, weights on the vertices. Here A to B, A to C, C to D we are connected. When we are connected into the B to C, so it is allocation into the loop. It is an allocation into the loop or cycle. So that's why we are removed into the B to C connection. So when we are not connected into the B to C, so what are those weights? Weights are there. Those weights we are assigned. So A to B is an a 4, A to D is an a 5, C to D is an a 2. So when we are finding the sum of the total weight values, the total weight values, what are the sum of the weight values are, so 4 plus 5 plus 2, so total is having 11. So total is having 11. So based upon this tree, without loop, we are finding the total sum is, and the weights are 11. So again we will discuss this one. So here the second tree. So now we are finding of the second tree. So we are not connected to the A to B. So when we are connected, it is an allocated into the loop. That's why we are not connected into the A to B. Second property, second possibility chance. So now we are finding of the second possibility chance. So when we are finding the total number of weights is an, so 1 plus 2 plus 5, total is an 8. The total is an 8. So total weights are the 8. So again third one. So when we are not connected the C to D, the C to D is not connected into an in this tree. So when we are finding this total, the weights are the 10. The total weights are the 10. So another possibility tree we will define, or we will construct as an, so if C A to D is not connected, again when we are checking this one, it is not a cycle. So when we are finding the total weights are the 7. So again we have the another possibility chance A to D. So the total sum of the possibility is an, so both are same, the both are same. So when we are finding these three ones, when we are finding those fours, so here when we are observed here, so those are the properties. Here first one, there is no weight values. Without looping we are constructed trees, okay. So again with the weight values we are constructed trees. So the total sum of the weight values are different weight values. So based upon this different weight values, so next we are going to the minimum cost spanning tree. So because of, so here different weight values we are identified. So why we are identified different weight values? When we are without looping, based upon this tree, without loopings we are identified by the different values. But then we are identified by the this is another example for undirected graph. What are the possibility chances in a spanning tree? So these are the possibilities of spanning trees. So without loop we are constructed into the possibilities are 4 trees. So then we are discussed into the minimum cost spanning tree. This is the main important, we are discussed into a minimum cost spanning tree. So in this minimum cost spanning tree is one of among all spanning trees with the smallest total cost, to find out the smallest total cost. So here, so lot of weight values, total values is there. We find out in the smallest value, to find out the smallest value. So in the smallest value, so here the graph is there. This is the undirected graph. In this undirected graph, when we are finding the so without loop, so this is the smallest possibility weight values. These are the smallest possibility weight values. Based upon this based upon this A to B, B to C, C to D, the weight values, based upon the weight values, this is the smallest cost of the spanning tree. So 1 plus 2 plus 3, that is the 6. Total value is equal to 6. Okay, so another we have a possibility. So here A to B, okay, A to D. Okay, so here we are using of the C. So here when we are using of the weight value is an 1, weight value is an 5, weight value is an 2. So when we are finding 1 plus 2 plus 4, that is the 7. So without loop we are given the so many possibilities. Here we will discuss into the so many possibility trees. Earlier we are discussing the so many possibilities. So again we will construct so many possibility trees. So we are finding into the smallest cost. The smallest cost is the this one. So now we will find out into the this one. So what are the applications of minimum cost spanning trees? Nowadays lot of examples is unavailable in living days. So what are those using of the minimum cost spanning trees? These are the applications. That is the computer networks, how to connect a set of computers using the minimum amount of wires. Everywhere we are using the in computer labs. This is the main important of the minimum cost spanning tree. So another example is application is an civil network plannings. Another application is an computer network routing protocols. And finally, so what are the one of the application is an cluster analysis. Okay, so for example, one of the application I will discuss into the house wiring. Okay, one house we will connect it into the wiring connection. So here we have a hall, bedroom, kitchen, so children bedroom. So these are the planning we will connect it into the wiring, house wiring. This is the main important. So here when we are using the computer networks and when we are using the house wiring, so we will find out in the smallest cost of the house wiring. So this is the one of the application of the minimum cost spanning tree. So in this minimum cost spanning trees there are 2 algorithms. One algorithm is a Kushkal's algorithm, another algorithm is a Prim's algorithm. There are 2 algorithms are the minimum cost spanning tree. So Kushkal's algorithm and Prim's algorithm. So how it will be worked in a Kushkal's algorithm, how it will be worked in a Prim's algorithm. So we will discuss in these topics. So now we will go to the Kushkal's algorithm. So here the Kushkal's algorithm, the minimum cost spanning tree or minimum weight spanning tree for a weighted connected undirected graph is a spanning tree with the weight less than or equal to the weights of every other spanning trees. In Kushkal's algorithm, sort all edges of the given graph in a increasing order. Then it keeps on adding new edge and nodes in the minimum spanning tree if the newly added edge does not from the cycle. It cannot be formed in a cycle. It picks the minimum weights edge at first and the maximum weight edge at the last. To find out the minimum weight edge is the first we will connect it, and maximum weight we will connect it to the last one. Thus we can say that it makes a locally optimal choice in each step in order to find the optimal solutions. So when we are finding, this is a greedy algorithm. What is the greedy algorithm? Greedy method, it solves the problems by making the best choice that seems best the particular moment. So this is the algorithm for the Kushkal's algorithm. So we can find out in the 3 steps. What are those 3 steps? First, sort all the edges in non-decreasing order of their weights. Okay, so to find out the non-decreasing order their weights. So second one, pick the smallest edge. To find out the pick the smallest edge. When we are picking the smallest edge, if cannot be cycle, it cannot be cycle or not formed in a cycle, we are included this edge. Otherwise, it discard that edge. When the form in a cycle, we are rejected that edges to connection. So third step, so repeat the step 2 until we are finding the v minus y edges into the spanning tree to find out the spanning tree. So this is the example for the minimum cost spanning tree in Kushkal's algorithm. So this is the Kushkal's algorithm. So here we will find out into them. So it is a graph. In this graph is having some of the vertices and some of the weights. So what are those vertices? 0, 1, 2, 3, 4, 5, 6, 7. These are the vertices. Okay. So what are those edges? 0 to 1 is on a 1 edge and 0 to 7 is on a 1 edge. So 1 to 2 is on a 1 edge. So 1 to 7 is on a 1 edge. Again we will find it 7. 2 to 8 is on a 1 edge and 2 to 3 as a 1 edge and 2 to 5 as a 1 edge. So on, so on, so on. Okay. So here the graph is having a vertices and edges. So each vertices and edges is having a one weight value. This is the main important. Each vertices and edges is having a some weight value. Okay, based upon the situation, we are finding of the small first. This is the Kushkal's algorithm. We are finding the minimum cost value. First, we are finding the minimum cost value. That is the minimum weight value. Okay, so first we are finding the minimum weight value. First, minimum to maximum. Okay, we are finding the minimum to maximum. Here we can check it here. This is the minimum. Okay, least value. When we are compare the cost value or weight value, it is the least. So here 2. Again we find out into the minimum value 4. Okay, so next minimum value 6. Next minimum value 7. Okay, so here you can check it here. The total number of vertices. How many vertices is there? 9 vertices, and total edges are 14. So here you can check it here. I write down here. So 0, 1, 2, 3, 4, 7, 6, 8. So these are the vertices and these are the edges. 0 to 1, 0 to 7, 1 to 7, 1 to 2, 1 to 7. These are the edges. So it is having a this graph. In this graph is having a 9 vertices and 14 edges. So the minimum spanning tree formed will be having a 9 minus 1 edges. That is called the vertices minus 1. It is the V is an a 9. So 9 minus 1 equals to 8. So when we are finding the total trees, we will find out into the 8 trees. We will construct 8 trees. 8 trees we will construct and to find out the minimum cost spanning tree by using a Kushkal's algorithm. So here weights and sources to destination. So weight 1 or cost 1 is source 7 to 6. Okay, weight 2, that means cost 2. So the source is 8 to 2 and 6 to 2. These are the previous graph. Yes. Okay, now based upon the situation we will construct first one, which is the smallest weight. So 7 to 6 or 6 to 7, whatever it may be, it is an undirected graph. We can construct 6 to 7 or 6 to 7 or 7 to 6. So when we have this one, so this is the weight 1 is in a smallest graph. This is the first step. Now pick all the edges one by one from the sorted list of edges. So first we will we find out in the step 1, pick edge. 7 to 6 is an a smallest edge, so it is not formed in a cycle. So then we will add into a minimum cost spanning tree by using Kushkal's algorithm. So the cost is an 1, 7 to 6. Again pick the edge 8 to 2, no cycle is formed, include it all edges 8 to 2, the minimum cost spanning tree. Okay, so again to 6 to 5, the minimum cost spanning tree. Okay, so here when we are finding here all those things, so we will find out into the minimum cost spanning tree. So minimum cost spanning tree. So by using minimum cost spanning tree, so we will construct it, and so this is the second step and this is the fourth step. It is cannot be allocated into the 0 to 1. 0 to 1 when we are connected, so it is not a form in a cycle. So next we will construct into the 2 to 5. The 2 to 5 is connected, the edge, so the cost is 4. Again we will connect into the 8 to 6, the pick the 8 to 6. So since including this edge results in a cycle, discard it. The pick 2 to 3, no cycle formed, include it 2 to 3 in the minimum cost spanning tree. So again pick the 7 to 8. So here when we are connected to the 7 to 8, it is an allocated into the cycle, so it is a discard 8. So again it will find out into the, so 1 to 2, when we are using the 1 to 2 is connected, it is collected into the cycle, it is connected into the cycle. That's why it is not a form the connection. So 1 to 2, because of it is a cycle, so then discard the link. So this is the algorithm for the Kushkal's algorithm. So when we have the graph, when we have using a number of the graph is having a vertices and edges, it is a form when we are pick the any weight values or entities. So when we are using of this vertices to edges, so is there any form into a cycle, we cannot be allocated into the process. So when this process we can find out into the structure. So then we will find out into the Prim's algorithm. Next we will discuss into the Prim's algorithm. So Prim's algorithm. So when we are using of the Prim's algorithm, so first we will discuss into the Prim's algorithm. So start with minimum cost edge. It is finding into the starting with an minimum cost edge. Select next minimum cost edge I to j such that I is the vertex already included in the tree, j is the vertex not yet included. Okay, it continues the process until the tree has n minus 1 edges. So we find out into the algorithm process. Determine the arbitrary vertex as a starting vertex of the minimum cost spanning tree. Step 2, follow the step 3 and 5. Our vertices are not included in the minimum cost spanning tree. Step 3, find edges connecting any tree's vertex with the finding vertices. Find the minimum among these edges. and the chosen edges the minimum cost spanning tree does not form in a cycle, return the minimum cost spanning tree. If I can find out in the one of the example, this is the example for the Prim's algorithm. Here the graph, this is the graph is having a number of vertices and edges. Okay, so we will check into the vertices is an, so 1 2 3 4 5 6 7 8. Here these are the vertices. Okay, so here we will find out into the vertices. So here we will check into them. So we will find out in the first vertex 1. So first vertex 1. So in this first vertex 1, so is having a 1 to 2, 1 to 8. So 1 to 2, 1 to 8. Okay, so here when we are starting into a first vertex, that first vertex is having a next edge is an a 2 and 8. So here the 1 and 8 is the cost of the weights. So we will find out into this one which is the minimum weight value. So this minimum weight value is an considered, remaining is an discarded. Okay, so here this is the process will identified by the minimum cost value. So here both are, so 1 to 2 the weight value is an 1 when we are identified by the 1 to 2. Okay, so next 2. So here 2, the 2 is having a, what are those, okay, what are those edges. So 2 is having a 3 8 and 3 and 8. So 3 and 8. So 3 and 8 the minimum weight value is an 8 to 2. So now we will connect in the 2 to 3. So 2 to 3 is an having a weight. So again we will find out into the minimum cost value 2. So 2 is the, so what are the vertices is having 2 to 3 already connected, 2 to 9 and 2 to 6, 2 to 4. So here we will check into the 2 to 4 is having a 9 7. Okay, so is having a, so 2. So in these both, so which is the minimum weight value 2, that's why we are connected 2 to, sorry, 3 to 9. So again we will find out. So next which is the minimum cost value 3 vertex to another edge 6, the minimum weight value. Based upon the situation we will connect. So this one we are connected into the without looping, sorry, without looping we are connected into an tree. We are connected into an tree. So each and every one, so we find out into an constructed into an a tree based upon the vertex to edges, based upon the vertex to edges, each vertex is having a some minimum weight value. So we are showing the graph. So here the identified into the, which is the nearest value, nearest value I j. So which is the I is the nearest value, j is the, so I is the vertex, j is the nearest value. So which is the cost of the minimum value to find out the each and every one. Near j is the vertex in the tree such that cost j near j is the minimum among all choices near j. So we will find out into the near, the 3 is having a 2 and 4 is having a 1 and 5 is having a 1. So how many possibility chances is there? We will find out here. So when we are finding this cost of the minimum weight values is near 3, here possibility 3 to 2, the weight value is an 8. Here possibility, so many information we are connected, so many information we are connected. This is the algorithm for the Prim's algorithm. So when we are finding the any possibility vertex I to j, so in this I to j, when we are finding the edges into the minimum cost value E, to find out the value for by using the for loop, to find out the cost value I to 1, I to 1 and cost to I to j near the values, and so near the I value is and find out into the minimum cost spanning tree is and computed to the sorting values. Then we are finding the time complexity of the Prim's algorithm. By using this one, here there are 8 lines to take in. For the loop we are using the 12 takes. Okay, when we are using the any above algorithm, number of lines is an 8, for number of using of the loop L is an 12, so 17 and 18 for the loop line is an 22 is an order of n times, each is having a then 14th line is an order of n times, and 14 is an order of n square times. The total is find out into the order of n square times. So here the loop is an order of n times. Okay, it requires the loop is an order of 1 times, the based upon the order of n times and order of n times, they both are order of n square times. Total the prime by using the time complexity is an order of n square times. These are the basic differences between the Prim's algorithm and Kushkal's algorithm. Okay, Prim's algorithm and Kushkal's algorithm. So we know the Prim's algorithm. What is the Prim's algorithm? So by using Prim's algorithm, the vertex to connection. Here the vertex to vertex, it is an connected by the smallest weight value. Okay, so 2 again 4. Okay, so we are finding of the vertex to vertex. So here the 1 2 3 4 are the vertices. So 1 to 2 the weight value is an 2. So 1 to 2 weight value is an 2. So which is the we are finding here which is the smallest weight value here. So when we are finding the first is an vertex, here there are two possibilities, edges is there. By using these two possibilities we are selected into the 2 because of 2 and 3 compared to 2 and 3. So smallest weight value is an 2, then we are selected into the 2. So again we are finding the next 2 2 2 2 2, which is the connection 2 to 1 and 2 to 4. 2 to 1 already connected. So again we have a 2 to 4, the weight value is an 4. So again we are connected to the 2 to 4, the weight value is equal to 2, the weight value is equal to 2. This is the process. Vertices to and edges, it is an connected into the Prim's algorithm. But Kushkal's algorithm, it is not a one of the process. It is the we will find it in the smallest element. First we are connected the edges. Again we will find out in the smallest edges. So basic the information we will find out Prim's algorithm. Prim's algorithm is an near so side by side. So we will find out in the side by side. So side by side vertices we will find out into the construct into a tree without looping. So Kushkal's algorithm, nearby smallest cost of the value. Okay, nearby is called smallest cost of the value. We have the graph, on that graph we are finding into the smallest value. So which is the edge we connect into the smallest value. Select the shortest edge into a network to find out the next shortest edge into the edge to connection into the edges into a vertex to vertex to find out the cannot be allocation to the cycle. This is the problem we were finding into the what are the differences between the smallest Prim's algorithm and Kushkal's algorithm. So we can define into the what are the future work into any Kushkal's algorithm. So even after connection all vertices into a tree, algorithm will be connected into the meeting n-1 edges. So Prim's algorithm need to calculate the cost of remaining edges even through it makes a cycle connected. So these are the some of the questions to find out the spanning tree and constraints Prim's algorithm, constraints Kushkal's algorithm, analysis to find out the Prim's and Kushkal's algorithm. So thank you so much.